It's a vast universe out there, and NASA's newest telescope is giving us glimpses that reach back to the very dawn of time. But in one of its most surprising turns, the James Webb Space Telescope didn't look at the farthest galaxies or ancient starlight. Instead, it turned its gaze toward the closest and most overlooked planet in our solar system, Mercury. Mercury is notoriously difficult to study from Earth. Its tight orbit around the Sun drowns it in glare, and past missions have only managed to scratch the surface through quick flybys or limited orbital surveys. Yet when Webb's infrared instruments locked onto this scorched little world, something extraordinary happened. For the first time, Mercury was revealed in a detail no one had ever seen. And what Webb found was not just surprising, it was unsettling. The first images seemed routine enough. Mercury's sunlit face radiated intense heat signatures, its battered surface etched with craters, ridges, and scars of a violent geological past. Nothing out of the ordinary. But when the telescope's deep infrared scans probed beneath the top layers of rock and dust, subtle anomalies began to appear. Patterns started to emerge in the planet's crust, patterns that didn't look random at all. In several equatorial regions, Webb detected spectral signatures of metals and silicates that didn't match the surrounding crust, nor Mercury's known geological history. And these weren't scattered haphazardly. They were aligned. Linear features stretched for hundreds of kilometers, traced in precise geometric shapes, straight lines, right angles, even alignments with the planet's poles and orbital path. To seasoned geologists, it looked less like natural geology and more like something arranged, something designed. The deeper the scans went, the stranger the picture became. Faint but consistent heat signatures revealed vast cavities beneath the surface, like enormous chambers connected by tunnel-like corridors. They dwarfed any natural lava tubes ever seen on Earth or Mars. Even more startling, these voids seemed associated with concentrated deposits of rare metals, refined to purities far beyond what natural processes normally achieve. To some, it looked less like geology and more like construction. That was when the mood shifted. Inside the mission teams, conversations turned from excitement to unease. If these were ancient structures, who, or what, had built them? And why Mercury, of all places, a planet baked on one side to over 400 degrees Celsius and frozen on the other to nearly -180? Surviving in such extremes would require technology far beyond anything humanity has yet achieved. What unsettled the scientists further was the detection of faint, repeating energy emissions. They were weak, barely distinguishable from background noise, but consistent. Not geothermal, not magnetic residue. The signals had the stability of an active source, however small. In other words, whatever lay beneath Mercury's crust might not be completely dormant. The classification of the data only fueled speculation. Publicly, the Mercury scans were cut off, archived data quietly removed, and sanitized summaries issued with no mention of anomalies. Privately, some scientists were reassigned, their research redirected elsewhere. For others, the decision was devastating. Webb was supposed to be the crown jewel of transparency in astronomy, delivering discoveries to the world. Now, for the first time, it was being silenced. Yet the images lingered in the minds of those who had seen them. The regularity of the formations, the purity of the metals, the faint energy traces, they painted a picture too strange to dismiss. Natural explanations were proposed, of course. Perhaps unusual volcanic activity, perhaps ancient impacts that fractured the crust in symmetrical ways. But none of these theories fit the scale, the precision, or the alignments. The question that remained was not just scientific but existential. If these were the remnants of something artificial, then it meant the solar system had once been visited, or even inhabited, long before human history began. And if Mercury held such secrets, what else might lie hidden on Venus, Mars, or the frozen moons of the outer planets, waiting for a telescope like Webb to uncover them? Mercury, silent and locked in its eternal embrace with the Sun, gives nothing away. Whatever lies beneath its scarred surface remains sealed from public view. Webb's glimpse lasted only days before the curtain fell, leaving behind whispers of vast structures and geometry where none should exist. Perhaps they were illusions of data, perhaps not. But one thing was certain: Webb's infrared gaze had opened a door, and someone, somewhere, had decided humanity wasn't ready to see what was on the other side. Mercury continues its orbit, indifferent to the secrets it may hold. Webb has already turned its mirrors back to the stars, toward galaxies billions of light-years away. But for those who witnessed what it revealed on the smallest, hottest planet in our neighborhood, one question will never fade. What exactly did we find beneath Mercury's surface, and why was it hidden so quickly? When the James Webb Space Telescope turned its golden mirrors toward Mercury, it was supposed to be a routine scan. The smallest planet in our solar system had long been overlooked, its airless surface and blistering heat leaving little mystery for astronomers. But Webb's instruments, designed to peer across billions of light-years, detected something strange right in our own backyard. Beneath Mercury's scorched crust, faint pulses of thermal energy appeared. At first, they seemed like background noise. Yet the signals persisted. They didn't flow like the steady rhythm of volcanic heat or the occasional burst from tectonic faults. Instead, they flickered irregularly, almost as if following a process. To the scientists monitoring the data, this was deeply unsettling. Some argued it could still be natural. After all, Mercury is not completely geologically dead. As the planet cools, its surface contracts, creating thrust faults that sometimes release heat. But when Webb's readings were compared with maps of Mercury's known features, something didn't add up. The emissions didn't line up with fault lines or volcanic scars. They traced geometric alignments, patterns buried deep below the surface, connected like a network. That was when the whispers began. The word infrastructure circulated quietly among the few who had access to the raw data. It was a word that carried implications no one wanted to voice aloud. If there was infrastructure, then Mercury was more than a scorched rock. It was a vault. A place intentionally chosen for its stability, its lack of atmosphere, and its harsh conditions, perfect for preserving something across unimaginable spans of time. No one dared say what that something could be. Some entertained the idea of ancient construction, perhaps not of this Earth. Others wondered if Mercury was less a planet and more a time capsule, holding remnants of a civilization lost long before humanity ever looked at the stars. Theories spiraled into dangerous territory. Was it abandoned? Or was it left behind for a reason? But those who had seen the true data couldn't shake it. The geometries, the voids, the faint pulses, they suggested a system designed to last. Some speculated that Mercury's massive iron core might even serve as a power source, feeding whatever lay beneath with heat or magnetic energy, keeping it alive in a state of hibernation. The signals Webb caught may not have been random at all, but the last embers of a system built to endure for millennia. In secure circles, the discovery took on an almost mythical tone. A glimpse of something vast, like catching sight of a shadow through the clouds, visible for an instant before vanishing again. Independent astronomers tried to replicate Webb's findings with ground-based observations and old probe data. A few claimed to notice faint hints of the same alignments, but without Webb's infrared precision, their results were easy to dismiss. The absence of verifiable proof left the truth in limbo, preserved only in classified archives. The secrecy itself raised deeper questions. If one discovery inside our own solar system could be hidden so quickly, what else might Webb uncover and lock away? Venus, with its shrouded clouds, might conceal more than sulfuric storms. The icy moons of Jupiter and Saturn already hold oceans beneath their surfaces, oceans that Webb is fully capable of probing. If Mercury's anomalies were considered too disruptive, would those findings ever reach the public? From a scientific standpoint, the shutdown was a tragedy. Follow-up scans might have distinguished between natural geology and artificial design. They could have confirmed the depth, shape, and purpose of the subsurface features. Instead, the mystery was frozen in time, left unanswered by choice. For now, Mercury returned to silence. And yet, among the small circle of scientists who witnessed the raw images, the memory lingers. They had seen evidence that refused to fit within accepted planetary science. Geometric alignment stretching for hundreds of kilometers. Thermal pulses synchronized with no known fault or volcanic process. Materials too pure and too uniform to occur by chance. It wasn't random noise, it was a pattern. Whether that pattern belonged to an ancient engineering project, a forgotten outpost, or a system designed to watch the sun itself, no one could say. But the implications were clear. Mercury may not be what we thought it was. Its surface, battered and lifeless, could be hiding something extraordinary, something not meant to be found so easily. Today, Webb dazzles the public with glowing galaxies and exoplanet atmospheres. The world cheers, and rightly so. But in the background, whispers remain. They remind us that discovery is not always the same as revelation. Sometimes the most important findings are not announced, but hidden. And somewhere beneath the surface of Mercury, the anomalies remain, silent, enduring, untouched by time. Waiting for the day when eyes will once again turn toward the innermost